Okay, let's begin. Okay. Find the difference. So you are given an array A of length and n queries. Each query is equivalent to 20 cells and find. For each query, two indices I and J. L and R are okay. I'm given L and R. So it's that I should find two indices I and J. Determine that not exist and that AI not equal to AJ. Find different ways if kind of not exist. Number of test cases, length of array, array elements, number of queries, and the boundaries of query, and then does not exist to different profile, guarantee some does not exist. Okay. For each query, output 20 is separated with space I and j, for which I are not equal to such values don't exist, output I minus 1, j minus 1. Okay, fine. Separate the output for test cases with empty lines is not a mandatory requirement. You may, it's not a mandatory, fine. Mm, this is the array, and this is the queries. Between 1 to 5, I need to find an index, and this one not equal to 2. I think this can be done very nice, actually. It is kind of prefix with sliding windows or what. Or need to do is take prefix maximum, actually. Yeah, I think prefix maximum will work. Because let's say I have 1, 2, 1, 1, 1, and then 1, 2, 3, 4, 5. Then what would I say? 1, 1, 2, 2, 2. No, prefix maximum doesn't work because that is different things. I cannot determine what elements are there between and how many of them are in between. All in some two elements are that A not equal to. Okay, how can I determine that? Then let's say this thing. There's no, it's not possible to get AI equal to AJ. Why is it not possible? Because they both elements are one. I cannot iterate because I know code. Course it doesn't allow me to do that. If I go on this thing, both are not equal. One not equal to one, and this cannot be done. Now, if I see these both, these are also not possible. But if I see these thing, possible to get an index there, that property holds true. How can it do? 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 So what I'll be doing is I'll be putting array. What I have is position of one, 1, 2, 4, 5. Position of 2 is one position is this thing and two position is only 3. Okay. 1 to 4 5 position of 1 this thing is this thing. Okay. Okay, it's a better question. It's so interesting actually. I should guess see just in the subarray there exist two elements that they are not equal to each other. Okay. This question is so nice. It looks like a 8 as it's actually 900 rated question. I don't know what it's doing 1300 difficulty. And I also don't know why am I unable to solve this thing. 30, 20, 20, 20, 10, 20, 10, 20. If I go to index 1 and 2, there is 30 and not equal to 20, we can get it. So if I go to index 2 and 3, there are 2 and 3. Okay, I cannot get this thing. And also, I'll push this indices somewhere in stack where it occurs consecutively. Now, whatever my index which I'm writing, okay, if it is less than this thing and greater than this thing, I mean, if it lies within this thing, then my answer is -1. Else, what is the answer to printed? Okay, I need to print some indices, random indices, and I'll just print some 2 minus 1 and 3 plus 1. I think that will work. But actually, I need to see the case where it becomes -1 first. Then I think the second thing might become easier. Mhm. 30, 20, 20, 10, 10, 20. I need just a function always giving indices. Give me the right answer. Maybe I can take average of each of them. This gives an average of 20. But what if I get this also gives me average of 20. First 30, 60, and 80, 80 by 4 is 20. This doesn't work actually. 5, 2, 3, 4. 1, 2, 1, 4, 1, 3, 2, 3, 2, 4. So this is 1, 2, this is 1, 4. This is 2, 3. First of all, I need to see indices of consecutive elements. Okay, I need to look up the indices of consecutive elements. That's it. That is S of I minus 1 is equal to S of I plus 1. Okay, this is what I need to look for. Now, what will I do after looking at indices of consecutive? All I need to do is select them. And this is of 10. Now, what I can do is 1, 2, 3, 4, 5, and 6. And to push 2, comma 3, 2, comma 3, 4, comma 5. Now, when my query gives an index, let's say 2, comma 3, and first of all, I'll search if there is an index present in this set which is less than this index and also this index. I'll check an index which is less than this index, lesser than equal to this thing, index and there is an index which is greater than or equal to this thing in this set. Now, yeah, that is what I mean by finding the upper bound and lower bound of this bound. No upper bound, I mean not upper bound, but technically, see, this index will be more than this thing, greater than 2 or whatever index is present, and at the same time, there should be an index which is less than or equal to this index. How will I find that? Let's say there was some index, not 2 comma 3, 1 comma 3, and 1 to 3 all are continuous. So I'm finding 1 as an index which is less than or equal to this thing 2. And mm, so the set of consecutive indices of consecutive elements. mm, mm, Let's say my consecutive elements are 2, 3, 4, and 5. Well, let's take a good example actually. Let's say my set of consecutive elements were some 3 to 5, or let's say 3 to 6, and then some other were 8 to 10. So this is what happening. Now let's say my input query has been given as 4 comma 5. Then what my answer will be? My answer will be minus 1. If it is not minus 1, I'll just output the same indices if, according to my algorithm. If I go. Now if I see 4 comma 5, there should exist an index in as such that 4 is greater than 3 and also 5 is less than or equal to 6. So basically this is finding upper bound and this is finding This is not actually lower bound, but I can say this finding smallest element. Smaller or equal, it can be done using binary search. So the time complexity will be, it should be big of, time limit is how much given? 5 seconds, okay. It's big of t into n into q into log. Q is to be none, renewable, and this log n. Is it log n really? Or some n x log n actually? X log n or n log n, because I'm iterating through the element of both. I think it's only log n. I think. I think yeah, it's binary search is better approach. Smaller or equal to a target value. No, see what is he doing is finding smaller element to level. What is, wait, wait. Okay, this is binary search implementation. I'll just do this thing. I think we're done. In the binary search, we need to find the smallest element. Okay, if you are unable to find it, you will return -1. And if it is the -1, then what? It's a -1 in any of the case, and both answer will be -1. This is directly looking for upper bound. If there is no upper bound, then my answer will be again -1. So if I show it on the test case, let's say this is a test case. mm, 1 1 2 1 1. Okay, these are the consecutive indices. So let s of I equal to s of I plus 1. Now I'll be pushing 0, 1, 2, 3. I'll just pushing that one indices respectively. Then again I'll do minus minus to be done. Or else I'll just push something. I don't know. But I'll push back in the vector. What I'll push? 0, 1, 3, and 4. These are the elements of my vector. Now, when my first query is 1, comma 5, we convert it to 0, comma 4. Now, in this array, I'll search an element is greater than or equal to 0. If it is there, then I'll return the index of this thing, which is 1. And then if there is an element 0, comma 4, and then again I'll return the index of 4, which is 1, 2, 3, 4, which is 4. But it is possible to get here actually, according to my seed. But I have found indices, then my algorithm is wrong somewhere. But I feel like binary search needs to be implemented if it is to be done using binary search. How much time did I give to this question? 22 minutes. If I go with 1 comma 2, what will happen? The idea of pushing consecutive elements doesn't work. It's clearly from this thing that I'm getting indices. Okay, what I can check is the previous index of this upper bound should be 0. What do I mean is, if I have 1 comma 5 given in the query, converting into 0 by indexing 0 comma 4, and then I'll look for upper bound of 4. I found the index of upper bound of 4. Now in that vector, v of index minus 1 should be something which is less than or equal to this index whichever I have given input 0. Let's say my index was uh, let's say this was something not my query index something. Let's say this was something 2 to 4, and then my query index was 1 to 4. Then what will I do? Now v of index minus 1 shall be less than or equal to, so v of index minus 2 to is equal to 1. It's not possible. 2 is greater than 1. Means what? So whatever the index I am covering, this is the first consecutive index, this is the second consecutive index, 2 to 4. Now whatever vector ka index is there, second value, it should lie between these both. So for lying in this both, this index value should be, no, I mean the query value, whichever is there, it should be greater than or equal to p of index minus 1. Okay, this condition is next actually. So first of all, I'll find the iterator to upper bound. Then I'll see the previous element that should be greater than or equal to consecutive. If it is so, then I have found pair which are consecutive. I'll just output minus 1, minus 1. Or else I'll just output both indices because let's say I have 0, 1, 3, 4, the original one. And let's say I have tested for 1, comma 2. Now I'll look for upper bound of 2 in this array. Upper bound of 2. Oh, wait, I need to look for lower bound of 2. Yes, lower bound of 2. Let's say it is giving me 2 and the previous element is 1. So lower bound of 2 is 3 means 2 comes within this range and this is 1. So obviously the answer is hmm, oh, think. I need to think some other way because it's not working. I'm not sure what the idea. And then taking it as few number of files, files, while few minus minus. I'm still not okay with the logic of my algorithm. Actually, it's not okay. What can I do? Uh, 1, 4, 3, 2, 4, 1, 5. This is again not consecutive. I can easily find. The problem is with finding consecutive pairs. Okay, 30, 20, 20, 10, 10, 20. Hmm. Measure the consecutive indices. What I need to do is I'll record them somewhere. So 0, 1, comma 2 is recorded. 3, comma 4 is recorded. Okay. If I go and check this query, 1, comma 2 is present in the pair. Whatever index it should be given in my query should be within inside this. Let's say I have L1 comma R1 as the consecutive index and the query has given me L comma R. Then L comma R should lie within L1 comma R1 so that I will not find in such an index so that L not equal to A. No, I will not find an index. Yeah, it is true. Then my answer will be 10 minus 1. In what case will it return? Let's go the reverse way. 1 comma 4, this will give me a minus. This will not give me a minus because the elements are different, indexes are different. Also, if I see the set, they're present in the set, but not as the int. What if adjacent elements are different? What if adjacent elements are different? He's trying the reverse around. 1, 4, 3, 2, 4. And I'll store their indices where adjacent elements are different. And then whatever my query comes, let's 0, comma 4. There in the sequence of the elements. And just go with it. Let's say I have, again, if I go to the same test case, 30, 20, 20, 10, 10, 20, and 0, 1, 2, 3, 4, 5. Here adjacent elements are not different. Here, I mean, adjacent elements are different, and here adjacent elements are different, and here adjacent elements are different. Now, when I give a query, stating, let's say 0, comma 1. So 0 is present in the set. You can go with it. Print the same index 0, comma 1. Let's go with 2, comma 3. It becomes 1, 2. 1, comma 2. 2 is present. 1 is not present. At 1, neighboring elements are equal. That's why it's not present. At 2, neighboring elements are equal, but 2 doesn't matter. I need to find only 1. Okay, let's check for this query. Comma 2. 1, comma 3. Which is 2, comma 4. Actually simplified into 1, comma 3. Now what I'll check is, again, 1 is not present, 3 is not present. 1 is not present, 3 is not present. At 3, there is a consecutive index, that's why it's not present. At 1, there's a consecutive index, that's why it's not present. But 2 and 4 are present. So if 2 and 4 are present, it implies that at 2, there is something breaking it, and at 4, there is something breaking it. So then I'll see if the lower bound of this thing, least element than this thing, is present or not. If it is present, but what if the equal element is present? Even if equal element is present, it is fine. And for 1, I'll check the least or equal element is present or not. It is 0, this is 2. Least or equal element doesn't work, because I just tried that approach earlier as well. But what if there is a least or element like 1? What will I do mostly? Means what, there is a distinct element less than equal to 1. But I need to look for a distinct element which is track last different index for each position in array. 30, 20, 20, 10. What is this index? Last differing index for each position in array. Okay. Got it. What is it doing is, let's say this is the last differing index in array. So 0 was the last differing index till now. Now 20 not equal to 20 still 0. Now last differing index is 1. Now again last differing index is 1. Now again last differing index is 0, 1, 2, 3, 4, 4. And there is no last differing index for this thing. So this is the last, so this is also 4. Okay. Now what is it doing is, I'm giving query. So where is the test case? The second one. 2 comma 1. 2 comma 1. Let's convert it 0 base. 0, 1, 2, 3, 4, 5. And this is 0 base. What is this? 1 comma 2 comma 1. 1 comma. Wait, no, that is the answer actually. I'm asking about the query. That is 1 comma 2. 1 comma 2 it becomes 0 comma 1. Oh, I was distracted. If I go with this query 0 comma 1, I'm checking if there is a distinct element for this one. 1 comma 2. 0 is the last different index which is greater than or equal to less than or equal to 0. I mean L. So you can get it. Hmm. If I try for 2 comma 3, 2 comma 3 is 1 comma 2. But if I check last differing index, what do I mean is between this range I need to find some two elements that are not equal. So for this thing, the last difference index was 0 because yeah, and for this thing, the last differing index was 1. Wait, Both are differing at 0. Now here if you see 20, 20 not are not equal. Okay. No, no, this thing is shown by this thing, and for this thing are shown by this thing. So if I see large differing index of 2 minus 1, a of 1, it is 0. Correct. Large differing index is 0. I think I need to check for this also. Large differing index is 0 for it. So both have same large differing index. Answer is minus 1 minus 1. If they don't have large differing indices, then if they don't have the same large differing, I'll just simply print out their large differing indices. Maybe that's what he's saying. Large differing index for query alpha. Okay. Check if previous difference of r minus 1 is within range to find differing pair. What is the range to find? What does it mean by this thing? Previous difference of r minus 1 is within range to find differing pair. Previous different r minus 1 is 0. Okay, but I want some different pair between 1 to 20. Okay, now my last different index is 0, not 1 actually. So 0 is less than 1. 0 is not less than L. Then I cannot get, can't get different pair. Then what will I print? Minus. I need to check actually. Where did I erase this? I have 30, 20, 20, 10, 10, 20. Let's say 2 comma 4. 2 comma 4 I'm doing. The query becomes 1 comma 3 and the differing index of n minus 1, which is this thing. For this thing is 1 and this thing is 1 is less than or equal to 1. Okay, then I'll be getting up there. What will be that pair? What should I print? Anything I can pair. I'll just print not L comma R because since 1 is less than or equal to 1. Bro, this confused me. It confused me actually. But how can I see this is less than or equal to 1? The L thing, whatever my L is in the query, it should lie within the last differing index. So my answer to be minus 1. So P of R minus 1. This is the constraint actually. Now P of R minus 1 is what here? It is 1. So greater than or equal to 1. L is greater than or equal to 1. Is that so happening? Yes, it is happening. No, no, no. L should be greater than that actually. Is that greater than 1? No, it's not greater than 1. For my answer to be minus 1. Because if it is equal to the last differing index, it's both have same last differing index. So the zero, I mean, this is what is meant by last differing index. Difference is happening at 1. And let's say my L is also 1. So at 1, there is, I think I need to do it again. I'm not clear with what I have written. Because I have written 1 twice. 30, 20, 20, 10, 10, 20. Okay. Now this is 0, 1, 2. These are the indices. Just leave it for a while. Okay, now I'll write last different indices. Since this is not equal 0 with the last different index, these are equal 0. It's still the last different index. And they are not equal 1 is the last different. 0, 1, 2, 3, 4, 5. So 2 is the last different index. Now these both are not equal. Both are equal. So 2 is still the last index. But now these both are equal. Not equal. It is 4 is the last different index. And then I don't know what to reduce for this thing, but let's say just put 4 here as well. Because it's not being checked anyways. Now when I take L anyways decremented. Let me take for the case 1 comma 2 after decrementing, and let me take for the case 1 comma 3 after decrementing. Now what I'll be checking is previous of 1. Previous of 1, what is previous of 1? It is 0. Last different index was 0. And now I want to check from index 1. Okay, last difference in means what do I mean by this is last difference index for 2, the last index where difference has occurred is 0. Now I want to select an element between 1 to 2 range. So for me to make this element fall in that, for me, wait, for me to this element not to be equal to this thing, not to be equal to 2 at all. I should get the answer in terms of last differing index. For me, this last differing index is 0, but my current index is 1. So 1 is greater than 0. Answer is minus 1. Because I want last difference to have at the lower boundary, at least at this index. I want have to have last difference to have at least last difference should be at least at this index. This is what I mean. And last difference is previous of r minus 1 is done or equal to L. So this thing, previous of 2 is, what is previous of 2? 2. Now this 2 is greater than or equal to what? 1. Thus, I'm able to get an index. Now what will that index be? I'll just obviously print the last different index 2 and then lower bound 1 comma 2. That's it. Let me try for other thing. 2 comma 4 again. Now it's 2 comma 6. Let me try for this thing. It's 1 comma 5. Now what if I do pre of 4, which is greater than or equal to L. This is 1. Is it greater? Pre of 4 is basically 4. 4 is greater than or equal to 1. Then what will my answer be simply? I'll just print the index pre of 4 and then because my claim is that always it lies and my condition is also in this thing. And then I'll print lower 1 comma. There's 1 comma 4 working. Yes, it is. Maybe it is what the solution. Let's see the code actually. What did he do? R comma previous different argument. This one. Okay. He checked the same thing. It should be. First of all, I'll convert it into zero base index, and then it should be at least L. That is what I have also checked. Now, what is the outputting is? R and previous different argument. 1 plus 1. Then we can output. I'll try outputting this thing, whatever thing I came with. Hope that gets accepted. Now, first of all, take initial comma R, minus minus, comma R minus minus. Okay. Actually, I need to check for previous difference of R because for some index, if I see the previous differing index, for 3, let's say the previous differing index is 2. So then the least index, L index, whatever I'm getting, it should be at least greater than or equal to L. So that my query holds true. This was for one base indexing it took actually, but it's our previous differing index for that element. And then for this thing, what will it be? It will be 4 only. Greater than or equal to L, then answer exists. Wow. Why am I checking previous of I minus 1 in this? Hmm. No, my code is giving error somewhere. I need to check for that error. I came up with some other approach and the solution I came with other I cannot identify the approach. I need to correct my approach before going to the and I need to begin a test case. First of all, let me clear this actually. Hmm. Now, what are the queries given me for this thing is five queries have been given. One, two, two, three, two, four, two, six, three, five. Now, expected out 20, 20, 10, 10, 10, 20. When I just put the changed last change index, this is 0, 1, 2, 3, 4, and 5. And now the last change index is here, this is 0. Last change index is not here, still 0. Now changes happen here, it's 2. And then, so whatever last change index will happen, it will be at the current index. Right? And the last change happened at 2, and last change happened at 4. So it will be at current index. Hmm. Now I need to check for 1 comma 2. First of all, I converted 0 base index in 0 comma 1. Now at r minus 1, at this thing, what was the last change index at 1? It was 0. So what does it mean is the value which is different from this value is at 0th index. Okay, then it is 0. And then another condition is the value at that 0th index should be whatever the value at 0th index is there. I mean, whatever the index I'm getting, it should be greater than or equal to the left index. So this is true. Yes, this is true. So period diff of r minus 1. Why am I seeing for r minus 1? I need to see for r. Okay. Okay, this is a garbage value which I'm getting. Mhm. Why is it giving a garbage value? Hmm. Hmm. Now, what are the indices I need to print out? First of all, I will printing previous difference of R, and then R. Mm. -1 will very good. Okay. His understanding. So for my previous difference element is this thing. Previous difference of 2 gives. Mhm, mhm, mhm. There is no condition that I must be less than G. Let's say I'm given input 2 comma 3. Then previous of 2 is greater than or equal to 1. Previous of 2 is 2. 2 is greater than or equal to 1. So what will be just printing is previous of 2, which is the index as at which the change happened, and what else will I print? They both are equal. What does previous of 2 means? Previous index at which change happened. Change is happening at 2, that is okay. Then another index at which change is happening. And logically, if I see between 2 to 3, I want to see. It will be R. But what if previous and R are equal? They cannot be equal, right? Because if I see, mm, let's say this thing and this thing, I'm comparing between 1 and 2. So previous and R are equal. Let's say I'm doing between this. My subquery is 1 to 3. It reduces to 0, comma 2 and 0, 2 base indexing. And now what will I output? What will output is 2 and previous of 2. Previous of 2 is 2. But here they both are equal. 2 is equal to previous of R. Previous of R is what? 2. Because if I'm taking, R is 2 and previous R is also 2. R is 2 and previous R is also 2. I cannot output it. He's also saying it's an error. Why is it printing this thing? Maybe R and previous R that don't become equal at any point because previous different is something else and R is something else. Previous difference occurs at R. I'm saying that thing. What do I mean is previous element was different. At 2, I'm checking if previous element is different or not. It is saying that the element as index 2 is different from it's not consecutive. Okay, so it's the same element which I'll print. And another thing what I need to print is the left index, which is not equal. So I'll print something other else, or else I'll just print uh, now if I see this previous at 2, what is previous element at 2? First of all, he's taking an input in one based indexing. Okay, let's take input in one based indexing. It will be 2 comma 3. Now what he is saying is previous difference of r minus 1 is converting it to 0 based indexing 1 comma 2. So previous difference of this thing, whatever element. Now the difference, previous difference is 2. It is greater than or equal to L. L minus 1 is greater than or equal to 0. Either it should be greater than 0, either it should be equal to 0. Because if it is less than this thing, the answer is maximum for this case. Why is it getting valid for him? This is his previous differences array. Now he's taking 2 comma 3 as input. Now he's comparing previous difference of 2 with previous difference with L minus 1. What is L minus 1? It is 1. This thing with this thing which is 1. Now 2 is greater than or equal to 1. Exists a different element within the range. Means previous difference happened at 2. R minus 1 is 2. Okay, previous difference at 2 is happening at 2. Okay, and then it is greater than or equal to L minus 1. It is greater than or equal to 1. I is equal to 1 and then AI not equal to A minus 1. Previous is equal to I minus 1. So A2 not equal to A1. So what is previous? Previous is equal to 1. Actually, I made a mistake. Alright, let me just visualize this code again for the third time. 30. It is really frustrating to do. 30, 20, 20, 10, 10, 20. Okay. Now I'm taking what 2 comma 3 as input query, first query. First, let me make a previous difference array and then I'll proceed with everything. So, what is previous difference array is let me make indices 1, 0, 1, 2, 3, 4. Now let's see this thing not equal to I minus 1. Difference is equal to I minus 1. 0. Now this thing is not equal to this thing. No. Then it will be what previous. It will be 0. So this last difference element was 0. Its last different element was 0. Now its last different element will be 2. Its last different element will be 2. Its last difference element will be 4. This is how is it going. Okay. Mine was different. I have written 2, 2, 2, 4, 4. Okay. Now what was my array was 0, 0, 2, 2, 4, 4. Actually that is wrong because I'm checking last different element, not the next different element. I mean what I mean to say is different element is occurring at 0th index. Now the different element occurred at 0th index. Okay. Now the different element occurred at 20th index. So my this index will give me the value of this thing actually. What I ought to compare was according to my array r minus 1. Again, whatever 0 based I took, I have to take r minus 1 of that. Okay, now let's see, take with this thing. Now what is he saying is, if a of I not equal to ai minus 1. Now what is ai not equal to ai minus 1? Okay, this is done actually now. Going to first query, let me take 2 comma 3 as the first query. First of all, I'll convert into one based indexing according to my convenience. Now this index is what 0. Means next index I convert 0, but our left bound is 1. So we cannot take that. We move with the next query. Okay, let me take other query from the test case. Then let me take 2 comma 4. This will become in one base indexing 1 comma 3. Now what I'll check is okay, one different index is occurring at this thing. At 2 it was occurring. So mine it will be 2 first index and then another index will be r, and then I'll just convert it into one base indexing. It is simple. Now what my initial doubt was what it is equal. What do I mean is but they cannot be equal at any point of time because if a not equal to a minus 1, previous is equal to I minus 1. Okay. If 2 not equal to 1, A2 not equal to A1. Oh, finally. Hope this gets accepted. 'Why is the time given 5 seconds? It was simple checking of each query. Online this long answer on this one. 1 1 2 1. If this doesn't work, I need to go with his implementation. Hmm. It will work actually. The thing that is confusing me here is one based and zero based indexing. 1 based and zero based indexing confuses you. Done. Oh, it was a great question. Moving to the next one. Hmm. And glasses arranged in line, I have classes AI units of juice in it. Only from odd number classes, bring from even number classes. Find out contiguous subvariables between classes whether both may have the same amount of juice in total if only classes is subvariable construction into that. Question is short. I think it's dip 4. Dip for E question. Gone so far. This one is the question of dip 3. Okay. This one is, oh, it is of a graph. I need to study graphs. I'm not familiar with this thing. It's also D question of dip 3. Most all are from dip 3 and dip 2 only. I mean dip 4, I believe so. Okay, moving on this question. And glasses arranged in a line. I mean, these questions are very good. But the previous question was really simple. I mean, it wasted my time because I got confused with the one based and zero based indexing. Hope we don't waste it further. Lulia has seven glasses arranged in a line. The ith class of the units of juice in it. Okay. From odd number classes, dating from even number classes. To impress, want to find contiguous subarrays classes of that both linear with the same amount of juice in total. If only the classes in this subarray are considered, please help to do that. Find there exist two indices L and R such that one and AL plus AR is equal to AL L and R have the same parity and otherwise. Plus 2 is equal to A plus M. Otherwise, number of test cases, total number of classes. What they want to do is just make the odd sum equal to even sum. Okay. To find a contiguous subvariables, yes or no, pick a line. Fine. That's easy. So what's given to me is 132. There exists a subarray. Okay, it's not for all odd and odd events. How can I do this? Probably subarrays whenever they say sliding windows the thing, but sliding windows dangerous. I'm not much aware of this. Hope we do at least till the fifth or sixth question. I know. Today afternoon I'll be virtual contest at 8 p.m. Inshallah. Okay, 132. First of all, I need to know the odd indices. The indices are very confusing actually. They make things more worse. The confusion between odd index and zero based index. One, 2, 3, 4, 5, 6. Okay. Now L and R. 1 plus 2 is equal to 2 plus 3. They need to print yes and no. This is always yes. I can pick any subarray. And then if I go to this test case, 1, 2, 11, 4, 1, 5, 1, 2. Mhm. Sum of odd indices should be sum of even indices. I want to find a subarray. Let's break it. Find a subarray such that sum of odd is equal to sum of even. Hmm? Overall sum, if I see of odd elements is this thing. No such contiguous subarray works. Okay, pandas, when we get answer no and when we get answer yes, we need to look for that as well. See, 55 is too much. I cannot do that. What are the tags of this question actually? What is it related to? We compute last change index. Oh, what is ASU? Disjoint set union. Of course, two pointers. Who did it with two pointers? Is it really doable with two pointers? Oh yeah, I guess yes. We can do it with two pointers. But what if L is equal to 1 and R is equal to N for every query? Then I need to iterate. Let's say I want this element, this element. Okay, if they both are unequal, that's it, and this windows index. Or else, let's say these are equal, then I'll move my pointer to both. Then I'll move pointer to both. While L less than equal to R. Actually, it's crazy. I mean, using two pointers is nice. Yes, you binary search. I was thinking of binary search especially, but pre-computation is also nice. I mean, pre-computation is time saving. Best is pre-computation, but seeing the 5 seconds time and the n value, it is nice to do with two pointers as well. Mm. Okay, leave this question. Move to this one. 1, 6, 9, 8, 5, 55, 3, 14, 2, 7, 2. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if I take sum of all odd indices, 1, 9, 55, 7, and 9. This thing is too much actually, they're making it too much. Therefore, I cannot do it. Because if I take this thing, if I take this thing, this thing, this thing, this thing, 2, 6, 1, 5, 7, 8. I just need to analyze test case, there's no other option. In fourth test case, if I try analyzing by his thing, maybe I get some intel to proceed further. Because now I'm literally blank. If I say 1, 2, 3, 4, 5, 6, 7, 8. I have read this thing actually. If there exists L comma R such that AL1 plus AL2. Okay, I think I can do with prefix sum. Prefix sum of odd indices and prefix sum of even indices. Okay, what will I do after that? Maybe let's try. Pick L is equal to 2, R is equal to 8. If I do this thing, what will happen is if it drinks A3, A5, A7. Okay, A3, A5, A7, and the date drinks something, whatever one person drinks or even drinks, one person drinks or drinks. This thing, this drink, and this drink. Are they equal? 5 plus 2, 7, 7 plus 4 is 11, 11 plus 2 is 13, and here 11 plus 2 is 13. Let me try it using prefix of odd and prefix of even. Now, what is prefix of odd? Wait, 3 odd is having. I can compute in general prefix sum. It is 1, 3, 11 plus 3 is 14, 14 plus 4 is 18, 18 plus 19, 19 plus 24, and this is 25, and this is 27. But how can I tell which one is which thing? That's why I'm saying to make some friends again. Later on, we'll sort out how things are working. This is 1, this is 14, this is 16, this is 17, and 3 even. This is 2, this is 6, this is 11, this is what is 3 even? 11, and then 2, 4, 6, and 8. This is 13, 2, and then 13 is 2, 6, 11, 13. Hmm. Now I need to find some subarray alpha mass such that the sum is equal. Indirectly, I need to find some pair such that the difference between should be equal actually. Then I need to apply two pointers or what? Because let's say I pick it 3 to 7. Matlab 11 and 13. I've taken this thing. 2, 4, 6, 8. Then I've taken this thing. 13 minus 1 is 2. 17 minus 14 is 3. 16 minus 17 is 8. Okay. 16, 14, 2. 14, 17 is 3. 13, 6 is 7. 32 is see prefix as odd. Okay. I'm taking 3 is equal to 2 r is equal to 8. Okay. This is for what? 2, 4, 6, and 8. And this is for 1, 3, 7, and 1. Okay, okay, 1, 3. What is wait, I'm doing it again. Wait, this time pakka. Do it. Let's take the test case which is 10. 1, 2, 11, 11. 4, 1, 5, 1, 2. And this is what? 1, 2, 3, 4, 5, 6, 7, 8.